Hello and welcome to today's lesson. Today we be relating density to solids, liquids and gases. Specifically, we will learn that due to their close packing, solids have a relatively high density. Then, we will see that liquids have a lower density compared to solids because their particles are not as tightly packed. Lastly, we will understand that gases have the lowest density among the three states of matter because their particles are spread out and have a lot of free space between them. So far, we have delved into the particle model of solids, liquids, and gases, and have a basic understanding of what density means. Building on this foundation, we can now explore how the arrangement and movement of particles in solids, liquids, and gases affect their density. This lesson will enhance our understanding of material properties and why different states of matter behave the way they do. Let's start with solids. In a solid, the molecules are in a fixed, closely packed arrangement. Each molecule has a specific position and can't move freely. Imagine neatly arranging marbles in a box where each marble touches its neighbors. Because the molecules are so closely packed, there is very little empty space between them. This results in a high density. For example, if we compare a block of iron, solid, to the same volume of water, liquid, or air, gas, the block of iron will be much heavier. This is because the iron's molecules are tightly packed, meaning more mass per unit volume. Hence, solids generally have the highest density among the three states of matter. Now let's look at liquids. In this state, the molecules are still close together, but not in a fixed position. They can move and slide past each other, which allows liquids to flow and take the shape of their container. Think of a container of marbles again, but now imagine shaking the container so that the marbles can move around each other. Because of this movement, there are slightly larger spaces between the molecules in a liquid compared to a solid. As a result, liquids have a lower density than solids. Note that water is an exception, meaning ice is actually less dense than water, which explains why ice floats on water. This is due to the unique intermolecular forces of water, but don't worry, you won't need to know this for GCSE. Finally, let's cover gases. In a gas, the molecules are very far apart and move randomly at high speeds. They spread out to fill the available space in their container entirely. If you imagine releasing a few marbles into a big, empty room, you can see how much space there would be between each marble. Due to this large separation between particles, gases have the lowest density of the three states of matter. There's simply less mass in a given volume because the particles are so spread out. Before we conclude, let's explore a fascinating historical anecdote related to density. Archimedes' famous Eureka moment.
I, Archimedes of Syracuse, once faced a puzzling challenge presented by King Hero II. The king had ordered a crown, but suspected that the goldsmith had deceitfully mixed in silver. He asked me to discover a way to find out. One day, in the bath, a great revelation struck me. The amount of water displaced must be equal to the volume of my body submerged. Using the very formula we have spoken of today, finding density from mass and volume, I measured the crown's volume through water displacement and compared its mass using scales, finding it must indeed contain silver.
By understanding the density in solids, liquids, and gases, we gain insights into the fundamental properties of materials and how they interact with their environment. This knowledge is crucial for applications in various scientific and engineering fields, aiding in the design and innovation of new materials and technologies. See you next time.